Thank you. Good afternoon. I am Brian Robinson. I'm here to represent the molten salt reactor technology for the Office of Nuclear Technology R&D. I'll go through a small presentation outlining the 5 scopes of work that we are going to have for 2018, and then we'll have any questions at the very end. Our strategy is to assist in the near-term deployment of molten salt reactors, both salt-cooled and salt-fueled concepts, by establishing viability, developing needed research capability, and enabling technology, reducing cost, and accelerating development to facilitate industry success. We have a lot of FOAs that have been going out. While I'm not going to go through all of those, I will provide a brief breakdown of what those are in subsequent slides. One of the things that I wanted to do here was outline all of the different types of MSRs that are being developed. As you can see, our MSR campaign kicked off in 2018, and we are embracing all of these technologies for much of our R&D portfolios. We have increased our private-public partnerships, as you saw with ARC-15 awards, with X-Energy and TerraPower. That's continued also with support of our SBIRs and our recent awards for accelerating advanced nuclear in the United States. Many of our reactors here have been involved, submitted, or have received awards in those areas. So I'm not going to go through them, but I wanted to bring them to your attention so that you're aware of the multiple different designs to support molten salt reactors. As many of you may know, the Oak Ridge National Laboratory from 65 to 69 was the primary reactor-based experience for our molten salt research. I provided here just a small breakdown of that facility so you guys would have it. The MSRE is something that I will continue to talk about on to the next slide, and I provided just a brief example of the fuel that was provided into the MSRE. It's a liquid fuel reactor, thermal spectrum limited breeder reactor. It's about 7.3 megawatts and about 662 Celsius for its temperature. I provided the salt to the participants so you guys would understand what type of fuel was being run in it. And the program was canceled when another reactor system was chosen. More importantly, the new interest in the MSR is the fast spectrum or thermal spectrums, which we've received several of, liquid fuel or solid fuel, and we have diverse markets: base loading for electricity generation, process heat applications, desalination, water purifications, and remote locations. 7.1 for our scope. I have 5 of these, but I'm going to go through each one of them and read them so that everybody clearly understands what we're looking for. Proposals are requested to develop and demonstrate in a non-radioactive environment a modern equivalent to MSRE's sampler enricher with improved reliability and potential to serve as a technology model to guide deployment in future MSRs. Our key parameters are: we're looking at progress for corrosion, fissile material consumption and isotope distribution, fuel salt redox conditioning, and in leakage of coolant salt by measuring fuel salt compositions. 7.2. .2's topic: evaluation of 316 stainless steel lifetime and MSRs. We are looking for experiment projects to evaluate the combined corrosion and mechanical stress impact of 316 component service lifetime and designs. As we've been standing up the MSR campaign, one of the things that we've noticed is many of the vendors are looking to rely on 316 stainless steel, and we are looking to have more information on the component design, and also that will help us understanding the infrastructure to support much of the component development. Our current R&D has shown high temperature, neutron damage, and mechanical service requirements will cause material properties to degrade over time. Generalized and grain boundary corrosion are expected to weaken the surface, making it more vulnerable to erosion. A key design for a molten salt heat transport system is the maximum allowable fluid velocity. And lastly, understanding material aging under service conditions will support establishing an evidence-based flow specifications. 7.3. Radiation hardened vision systems. Demonstration of a multi-camera radiation hardened 3D vision system to continuously update the in-containment model status is requested. In addition, the demonstration of techniques to repair and or replace vision system components within containment is also requested. Key elements to consider: enabling the automation system or the operator to perform tasks is to provide real-time 3D visual updates on the positioning of the tooling, components, and surround structures. Number two, depending on the local shielding employed, the MSR containment environment may have very high radiation dose rates. The last point, radiation hardened remote tooling and operations have been developed in support of O&M in multiple prior high radiation environments. Our fourth area, molten salt mechanical filters. Experiment projects are sought that demonstrate fuel salt mechanically filtered performance and operational issues using non or low radioactivity materials. MSR our R&D has shown plating out corrosion resistant materials on the surface would be considered a positive protective effect. It is anticipated that mechanical filters will be used to remove fission products out of the salt. Under certain conditions, fissile materials may also plate out on the filters. Sintered nickel is a leading candidate structure to serve as a mechanical filter. Filtering out radionuclides has a number of complex interrelated issues such as monitoring filter conditions and performance, introducing and removing highly radioactive filter, cooling and shielding the filter once removed, and lastly, surveying the filter for fissile material control and accountability. These issues I have found to be very helpful and I provided this amount of detail because this is what we need to have kind of put the parameters around what we're looking for our R&D. That's why this one has so much detail on it. Number 5, shutoff valve technology development. On a molten salt flow loop designed and demonstrated MSR coolant salt, shutoff valves whose component technology would be suitable for qualifications under 10 CFR 50 Appendix B Quality Assurance Program. Again, I provided information here to consider so that you understand what we're specifically looking for. The primary coolant salt will be operated at somewhat higher pressure than a fuel salt to cause in-leakage in the event of a heat exchanger tube failure. Primary coolant salt lines penetrate radionuclide containment layers, providing a potential barrier bypass route. The ability to provide high reliability closures to the primary coolant salt lines on demand decrease the risk for radionuclide release. Valves may be a safety-related item as they could be relied on to mitigate the impact of postulated accidents. Valves should remain operable even under beyond design basis event conditions. And lastly, high reliability molten salt and safety-related shutoff valves with local activation energy storage have not been previously developed or demonstrated. Currently, I have David Holcomb on the dial-in on a video. He should also be able to table any questions right now, but I wanted to provide you my point of contact. Obviously, my name is Brian Robinson with my contact information, and David is below me. If you have questions now, you can certainly table them, and if not, then you can send emails or call us at these numbers, and we can then handle any questions. At that time, since I'm done, I will push it back to the audience for any questions.
Okay, we'll open up the line for David. David, I think your mic is back on, so please submit any questions you have for Brian and David over the next few minutes, and we will have them answered here. So, Brian, for RC 7.5, is the shutoff valve a generalized term for freeze seals for allowing dumping on the core with loss of cooling or high temperatures?
I don't believe that's a generalized term. I think those are two separate issues. David, you can expand on that if you want. I believe they're talking about freeze plugs. Is that correct?
Yeah, if you elect to use that as the mechanism for your valve, you certainly could employ freezing to do that on there. But generally speaking, a shutoff valve would be something which would operate reasonably rapidly. Think a containment isolation valve in an LWR. It's one of its properties is a rapid shutoff, and so you'd have to redesign a freeze valve to make it operate rapidly.
So the follow-up question there is, then it's okay to use other types of methods or other valves for salt dumping?
This isn't necessarily even salt dumping. This is a containment isolation valve, and it's intended to be on anything which is penetrating the containment boundaries.
Right.
And I would presume that most valves would be some form of a mechanical system.
Right. So I think the question is being directed towards a dumping of salt via a plug valve versus what we're asking here is a mechanically operated valve.
Now, as another follow-up to that question, can alternatives to freeze valves or other valves that are not actually valves be covered under this funding?
Can alternatives to valves that are not valves be considered? The answer to that would be no. This is a call specifically for valves for molten salt reactors.
For the stainless steel 316 tests, what types of molten salt are you looking for, chloride or fluoride?
We're looking for basically either, but as demonstrated by the industry support that we showed on slide 2 or 3, we do have industries that are looking into more of a chloride for fast reactors right now, but we certainly would take proposals for either.
We'll stay on the line for a minute or two longer to take any further questions. So if you do have any questions, please submit them to the system now. Is there any specific apparatus for testing the corrosion of stainless steel?
Wow. So, David, I'm not even sure if you know the answer to that. That certainly would go into our materials people. That question, I could table it and discuss it discuss it later or bring it out in an email. I'm not a materials person, but David, I'll kick that over to you.
I mean,
I know there's a range of tests.
the whole
Do you have anything in specific that you'd like to talk about?
Fatigue of this. That's why it's a combined test on there. And so you may be doing some fatigue testing. You may do a direct erosion testing, which tends to be a nozzle type structures. There's of course just direct metallography. There's not a single specific test because much like any other material, you look at the combined impact of the service environment on all its performance properties.
Is the mechanical filter designed for chlorine or fluorine salts?
Well, again, as I talked about before, about choosing one salt or the other, many of their industry outreaches now are focused on chlorine, but we would accept proposals from either. So we're not restrictive on chlorine or fluorine. David, if you have anything else, please provide it.
No, I think you'll have get more suspended things in the fluoride because it's got solubility limits. But either of these we are suitable for fluoride-based salts or chloride-based salts, and we will think that filtering is a general requirement for MSRs.
How do you envision max flow for 7.2? Pumps are expensive. Natural convection is more realistic.
Pumps are expensive, and they also are difficult to come by.
Again, in the testing on this, You may try to do something which involves pressure differential drive. I mean, certainly you can get fairly good flow velocities for temporary testing using a differential pressure that just requires a gas phase control. But you're correct, the testing, however, trying to achieve high velocities, which is what you were concerned with in erosion, you're not going to get that with natural circulation.
Going back to 316, for the irradiation damage in molten salts, do you have to use neutron irradiation?
We're looking for as representative as we can get, but we recognize there are financial limits on this. Yeah, certainly a huge irradiation campaign is beyond the scope of what's available financially. We're trying to get as good and as representative as we can, and that's why there's design and variation in this. We're hoping for good ideas.
And that's exactly right. I mean, to sit back and think that we're going to have an impact cost due to radiation would be, it's not a very realistic goal. But the concept is what can they bring forward? What are their proposals? What's their experiments and conditions? That's what we're really looking for.
Would ceramic coatings of stainless steel be an option as a treatment to enhance the chemical durability?
Well, I think any option is certainly something that we would look at. Whether or not it's the best option or the only option is probably the issue. But proposals like that, I'm not going to really narrow it down and say technique or type would be the most viable way of doing business. I would ask them to submit it, and we'll sit down and review it depending to all of the proposals that would come in.
Are you interested in creep and creep fatigue of 316 stainless steel at high temperatures without molten salt?
David, you can probably handle this question, but my understanding is that 316 stainless steel creep and fatigue issues, we have a wide database of information on that without molten salt environments. I mean, I guess we can always use some sort of surrogates or other conditions, but I would be much more specific into looking for an environment that supports 316 with molten salt.
Yeah, I agree with you. This is already an alloy which is in the high temperature portion of the Section 3, Division 5. So we've got established design limits for 316. Admittedly, it's for H, and we're looking for the general 316, which tends to overlap into H and L. But we're really looking for what happens now when you want to use this material in a molten salt service condition.
For 316L, is the corrosion and stress effect only limited to erosion type degradation?
Go
ahead.
Yeah, it's the full set of things you would have in service. So 316 it'll be stressed, it'll have neutrons, it'll have salt exposure, it'll have thermal cycle. What we're trying to do is to try to set some realistic experience-based limits on how does the lifetime estimations for 316 change when we put them into an MSR service conditions.
I would agree, and I guess the question was more specific around 316L versus 316. I guess that's the intent. But yes, we'd be looking at that with a whole host of other things, as David said. We're not looking at specific one area versus another.
Is only 316 of interest, or would 304 or other qualified stainless steels also be of interest?
316 is, I chose that one, and David and I talked about it because it seems to me the most viable option for industry for commercial support. There is some discussion for 304 because it's closely related to 316. For this call here, we chose it just because of its high, it's high on the selection system to get the most of the vendors. So again, we're more specific to 316 and not 304. Certainly, if somebody wanted to submit their proposals, I don't know why they would be splitting that hair between the two. but they can certainly submit it. But our call here is much more specific to 316. David, do you have another view on that?
We are following the guidance of the vendors. We just talked to the vendors, and more of them are, they've been considering 316. It's not that we're pre-selecting, saying hey, this is better, but this is what we're following from the vendors, and we're trying to be supportive of what their needs.
Okay, those are all the questions we have. Thank you, Brian. Thank you, David, for being here on the line to help answer some of these questions.